All right, welcome back everybody. We're going to continue on learning about quadratic functions. So far we've been learning about quadratic functions in something called vertex form, which is really easy to take a look at. We can picture the graph really simply. But when it comes to working with quadratic functions algebraically, we're going to often see them in something called standard form. And so it's going to be important for us to be able to bounce between the two, to go from standard to vertex and vertex to standard form. Just before we get started though, let's just do a quick recap of all the kind of terminology associated with parabolas and quadratic functions that you should be familiar with now. The first is that the vertex, of course, is this point of inflection where it goes from upwards to downwards. It's either the high point or the low point. If it faces upwards, then it is the minimum value, and if it faces downwards, if it's inverted, then it's going to be that maximum value. A couple of things we've talked about briefly. So there are, for example, there is an intercept. So there's a point where it's going to intercept the y-axis, and that's going to happen whether it's inverted or facing upwards. But the other thing that can happen, and that we'll talk about more in detail later, are these x-intercepts. And x-intercepts are the points where it's going to cross the x-axis. And we can see in these cases there are two x-intercepts, and there can be two x-intercepts, or there can be none, or there can even be one. And we'll talk about that in a little bit more detail later. Also want to just refamiliarize you with the terms domain and range. So domain being the values, the possible values in the x, on the x-axis that are allowed. And so a parabola, even though it goes upwards and gets steeper and steeper and steeper, it does go on forever and it never really goes perfectly vertical. So in theory, it can have any x value that is allowed. For the range, the possible y values, it'll have either a maximum or a minimum value that coincides with whether it's inverted or whether it's upright. Okay, so if we start off with an equation like this, which is something we've been familiar with so far, y equal to x minus 2 squared plus 3, that's in vertex form. We're going to expand that out and see what happens. So by expanding it out, I'm just going to perform this multiplication here. And so if I FOIL this out, as we learned before, I get x times x and then so on. I'm going to multiply all across. I'm going to distribute across those two brackets. So I get x squared minus 2x minus another 2x and then plus 4, and then don't forget I've got my plus 3 on the end here. If I collect like terms, this can turn into x squared minus 4x, and then 4 plus 3 is plus 7. And this right here, what I've done is I have now moved this into standard form. So a standard form quadratic function is one that has the general form that you see right here. So this is my general standard form. And we say it's f of x is ax squared plus bx plus c. Compare that to our vertex form, which said y is equal to ax minus p squared plus q. And so you can see there are a couple of, well, there's one thing that those two have in common, the a value, but then two other variables that are new, which is the b and c values. So really quickly what those do, a is the same a that you know and love from vertex form. So it's going to, it's really going to affect the shape, how wide or narrow the graph is, and it's going to affect the inversion, or which way it faces, whether it's upright or it's inverted. The b value here that we see right here, so b is going to shift the position of the graph. And we'll look at that a little more later as well. And last but not least, c determines the y-intercept. Remember that the y-intercept occurs when x equals 0, and you can see that if I put in f of 0, I substitute 0 in for x, both of these first terms would disappear and I'd just be left with c. So we'll just do a couple of practice problems where we go from vertex form into standard form. And this should be fairly straightforward. We saw one already. Basically, I just need to expand out distribute across my brackets and then collect like terms. And so this is going to be negative 3, got x plus 1, and then that's x plus 1 again, minus 5. So don't forget this leading a term here when I FOIL out. Negative 3. This is going to FOIL out to x squared plus 2x plus 1. And I just kind of skipped a step there. By now, hopefully we're familiar with that. And now I need to distribute that negative 3 across everything inside the bracket. So that becomes negative 3x squared minus 6x minus 3. And I can drop the brackets. I've got the brackets there, but I can drop them at this point and just collect my like terms, which is this negative 3 and negative 5. So negative 3x squared minus 6x, negative 3 minus 5 is minus 8. And there I go, I'm in standard form. So in this case, just a reminder, A in this case would be negative 3, B would be negative 6, and C would be negative 8. Okay, let's do another one here. So f of x equals 1/2 x minus 2 squared plus 3. And so again, I'm just going to leave this 1/2 there for now, and I'm going to expand out my brackets. And so this is going to become 1/2 x squared minus 4x plus 4. And I've got a little plus 3. Distribute that 1/2 across the brackets, and I get 1/2 x squared minus 2x plus 2. And then don't forget the plus 3 at the end. Collect like terms. 1/2 x squared minus 2x plus 5. And I'm done. Okay, so going from vertex form to standard form is fairly straightforward. Unfortunately, going the other way around is a little bit more challenging. So we're going to have a few different strategies to do that. I'm going to show you one strategy today which will work, and it's good, but frankly, it's a little bit of a, feels like a little bit of a cheat code where it gets you the answer, but it's kind of hard to, we don't really necessarily understand what we're doing while we do it. So there are some formulas that we can come up with. We're actually going to derive them right now. Some formulas that will allow us to jump from standard form back into vertex form, okay? Okay, so I'm just going to start off by writing out my typical vertex form equation here, where I've got y is equal to a x minus p squared plus q. And what we're going to try and figure out is, how does that relate to standard form, which is y is equal to ax squared plus bx plus c. And so, if I were to expand out, I'm just going to leave this in the general form, and I'm going to expand this out and kind of see what I end up getting. So this could be written as y equal to a x minus p times x minus p plus q. And if I expand out this x minus p, this term here, we would see that we would get x times x is x squared, and then negative p times x, and then I'm going to get another negative p times x. I'm going to get minus 2px, and then negative p times negative p, I'm going to get plus p squared. And then of course I've got my plus q out there at the end. I'm then going to expand across, like, so this a term that's out front here, I'm going to multiply that across the entire thing, and I'm going to end up with y is equal to ax squared minus 2apx plus ap squared plus q. Okay, and remember in all of this, the a and the p and the q, there's just still some sort of constant, depending on what the variable is, or the equation is. So the first thing I want you to notice is, really, if I want to know what is this term going to be in standard form, this a is going to be the same as this a right here, because you can see the ax squared term and the ax squared term, well, it's still intact. But the b term right here of my standard form, what is going to be multiplied by just the x term? Well, that is going to be all of this. So this whole thing right here, negative 2ap, is what gets multiplied by x. So I guess what I'm saying is that b must be equal to negative 2ap. And then for c, well, for c, I have all of this. This is all a constant at the end here. ap squared plus q, that whole thing is constant. There's no x term there. So I guess what that means is that c is going to be equal to ap squared plus q. And so remember that I'm going to use these formulas to go from to go from standard form into vertex form. So I'll know what A and B and C are. I won't know what P and Q are. And so I'm going to use this. I'm going to rearrange these formulas so that I can solve them for P and Q. So for example, if I divide both sides by negative 2A, I would get a formula that says P is equal to B, or negative B, over 2A. And so that formula right there is going to allow me to find P as long as I know B and A. And then same thing for this other formula. I'll know what C is. I won't know what Q is. So I'll rearrange this and minus AP squared from both sides, and I'll get Q is equal to C minus AP squared. And so there is my second formula. Now, worth pointing out that I will know A and B and C because I can just read them right off the standard notation equation. I'll need to find P first because this formula here I'll be able to find with just B and A. But to find Q, I have to solve for P because it's part of that equation. So let's try one out. So I've got this equation, f of x equals negative x squared minus 2x plus 3. So I'm just going to write it out here so it's nice and clear what my A and my B and my C are. A in this case, there's a negative sign there, so A is going to be negative 1, B is going to be negative 2, and C is going to be 3. So solving with this equation, I get P is equal to negative B over 2A, which is going to equal negative 2 over 2 times negative 1. That's a whole bunch of negative signs, so let's not get confused by them. Let's make sure we keep track. This negative times that negative is going to cancel out and make a positive. But then when I divide 2 by 2 times negative 1, I'm going to be left over with a negative sign. So 2 divided by negative 2 is just going to be negative 1. So that's my P value. And then my Q value is going to equal C minus AP squared. So C is 3, and I'm going to subtract from that A, which is negative 1, times P, which is also negative 1 squared. And that's going to equal, well, this negative 1 squared is going to cancel out that value. And then this negative sign and that negative sign are going to cancel out. And I'm going to end up with 3 plus 1 is 4. Okay, so there's a couple more examples here, and this would be a great chance for you to kind of just practice what we just learned. So go ahead and hit pause on the video, try these, and then come back for the solution. Okay. And now that you definitely hit pause and definitely tried all of these, let's see what I get. Again, I'm going to lay out A and B and C because I can read those right off of this this equation here. So I've got 3 for A, I've got negative 6 for B, and I've got 4 for C. Remember that my equation, which I got right here, or my formula, I should say, my formula for P is going to equal negative 2B. Negative B over 2A. So solving for P, I get negative times negative 6 divided by 2 times 3. Well, negative times a negative is going to cancel. And so I have 6 divided by 6. So that means P is 1. Solving for Q, Q is going to equal C minus AP squared. Let's make sure that's right. It is. C minus AP squared. And so C is 4, and I'm going to subtract from that 3 times P squared. Well, P was 1 squared. So 1 squared is 1 times 3 is 3. 4 minus 3 is just 1. And so my equation in vertex form is going to be Y is equal to A, which is 3, times X. P is 1, so X minus 1 squared, and then Q is 1, so plus 1. And that is my vertex form. All right, let's do another one here. I've got, I'll do my A, B, and C. So A is going to be negative 1/2, B is 4, and C is 2. So solving for P is equal to negative B over 2A, which is going to be equal to negative 4 divided by 2 times A, which is negative 1/2. This negative cancels out with that negative. 2 times a half is just 1, and 4 divided by 1 is just going to be 4. So then solving for solving for Q is going to equal C minus AP squared. And C is 2 minus A, which is negative 1/2, times P squared, which is 4 squared. So again, these negative signs cancel. 4 squared is 16, times a half is 8, 2 plus 8 is 10. And so putting it all together into my equation, I've got y is equal to A is negative 1/2, x minus p is 4, so x minus 4 squared plus q, which is 10, plus 10. And there we go. All right, so that's it for quadratics and standard notation.